What's up, everybody? Mr. Kozad back again for another video lesson. Our topic for today is on solving systems of linear inequalities, I should say. If you're in my class currently, this is section 3.2 from our textbook. Again, if this is your first video with us, welcome. Thank you for finding me in these videos. I hope you find them to be helpful. As you go through this, please feel free to pause, rewind, fast forward, start and stop, whatever you need to do to be able to use this video effectively. I hope that it meets your needs. I definitely suggest getting a sheet of graph paper if you have one available to you to go through some of these graphs, because we're going to want to kind of see what happens on an actual coordinate plane through some of this stuff. So this video shouldn't take us too long. So let's jump right in. Okay, so we see, similar to a system of equations, a system of inequalities is going to have more than one inequality. So what we're specifically looking for here is, we know with inequalities that we're going to shade portions of this coordinate plane. And when you have a system of inequalities, you're basically looking for what's called the overlapping shaded region. Okay, so that means that the part of the graph that's shaded twice, if you will. So the first step on solving these types of problems is to graph the boundary lines. So I'm going to graph two different boundary lines. I'm going to do this first one in green. So that form is really, really convenient to graph. It's slope-intercept form. So I go up 5, drop a point, and then my slope is -2. So I go down 2 over 1, down 2 over 1, and I'm going to repeat that process just a few times. I'm going to go the other way as well, okay? And then before you draw your line, remember to look at the symbol, okay? If the sign is or equal to, okay, right here, if it's or equal to, remember you need a solid line, okay? So that's what we're going to do. We're going to draw a solid line that connects all those points. All right, so now, I'm not actually going to shade yet. Okay, I'm going to wait and shade at the very end, but I am going to figure out which direction to shade on that particular inequality. So again, we pick a test point that's not on the boundary line. I'm going to test 0, 0, and when I plug that in, I get 0 is greater than or equal to -2 times 0 plus 5. It gives me 0 is greater than or equal to 5. So remember, at this point, we decide whether this statement is true or false. This statement is, in fact, false. So that means we would shade this away from the origin. Now, like I said, I'm not going to actually shade that. I'm just going to write myself a little arrow, look up here at the very top of the graph, a little reminder that I'm going to shade to the right of that line. Okay, so now I'm going to switch colors, and I'm going to move on to the second inequality. Y is less than 1/2 x minus 5. So again, this format is super convenient to work with. I'm going to go down to the y-intercept at -5. 1, 2, 3, 4, 5. Drop a point. My slope is 1/2, so I go up 1 over 2. Do that a few times so I can get a good idea of where this graph's going to be located. Now, before you draw this line, remember to look at that sign, and this should be a dashed line because it is not or equal to. It's strictly less than. Okay, so same deal. I'm going to test a point. So I'm going to test the origin again. Remember, the rules on the test point that you pick is it just can't be on the boundary line that you're dealing with. So I plug a 0 in for y and a 0 in for x. So I end up getting 0 is less than -5, which is also false. That's also a false statement. So there, what I'm going to do is I'm going to shade the red line. I'm going to shade that away from the origin as well. So then what you look at here is you've got two lines that are being shaded. The green line's being shaded to the right, and the red line's being shaded down below. So the section of that graph that would be overlapping would be this little section right here. Make this a little bit bigger here. There, that's better. It's this little section right here. And what this little section that I'm shading is, that's the overlapping shaded region, and that section of the graph represents all of the ordered pairs, the x and y combinations that make both inequalities true at the same time. Okay, it's called our solution region. It's the part that's double shaded. Okay, let's try another one. Okay, example 2 is to solve this system by graphing. I chose this system because it gives you a little bit of a review on vertical and horizontal lines. So as we graph y is greater than or equal to 4, we have to remember what that boundary line looks like. So y equals 4, I go up 1, 2, 3, 4, and that is a horizontal line. It's solid because it is an or equal to inequality. And if I want the values that are greater than y greater than or equal to 4, that's going to be shaded up above that line. Again, remember, I'm not going to do any shading yet because I'm looking for the overlapping shaded region here. So let's do x is less than 3. Let's do that next. So I come over to x equals 3, and I'm going to draw a dashed vertical line at x equals 3. Okay, x equals 3 is a vertical line, and it's dashed because it's not or equal to. So if I want everything less than 3, that's going to be everything to the left of that line. So there you go. Now you can see that your overlapping shaded region here is going to be this little rectangle at the very top. And again, what that region represents, it represents all the combinations of x and y, all the coordinates, the x and y combos that make both inequalities true at the same time. Okay? Okay, the next problem, again, is a different system that you're going to graph. This is nothing really new other than the form. So what I would do is I would pause the video here, and I would try to complete this problem on your own, and then turn it back on when you finish. Okay, welcome back. I hope you actually took me up on that advice to practice this. As you see here, we've got two equations that are both in standard form, so not super convenient to work with. So the way that I graph standard form is I do the x and the y intercept. So for the y-intercept, you make x equal to 0, and you'll get the y-intercept to be 1. And then the x-intercept, you make y equal to 0, and then you solve for x, and you get negative 3 over 2. Okay, so that's 0, 1. And then negative 3 over 2 is negative 1.5. Okay, dashed line, because it is not an or equal to inequality. So draw on your dashed line. Okay, then we need to figure out on that line which direction we're going to shade. So I'm going to test a point that's not on the boundary line. Okay, I'm going to use 0, 0 again because that's not on the boundary line. And that's actually pretty easy on an equation like this. So plug a 0 in for y and x and test. So we end up getting 0 is less than 3. That is a true statement. So I'm going to shade this graph towards the origin. Now before I do the shading, remember I just put a little arrow up there. Okay, and now let's mess around with the second equation. So the second equation, again, I'm going to get the x and y intercepts. So that would be 0 for x, and then y is 3 over 2. And then my x-intercept, 0 for y, and I get my x-intercept to be 3/4. So if I be kind of careful on these points are kind of close to each other. Okay, so you have to be a little careful. So that should have been a solid line. Check your graph. Was it solid? And again, we can test the origin on this inequality as well. So plug 0, 0 in for x and y, and then ends up giving me 0 is greater than or equal to 3, which is not true. That's false. So I'm going to shade away from the origin. So then if you look at both lines and the directions that you're shading, you'll see that your overlapping shaded region is this section down here. And again, this overlapping shaded region represents all the combinations of x and y. Hopefully you're not super OCD because I'm not going to be able to shade all that in, sorry. But this represents all the combinations of x and y that make this system of inequalities true. Now, the last problem that we're going to look at together is a lot of fun. It's a problem where we have to work backwards, okay? So we're going to write a system of inequalities that would produce this graph. Okay, so you see a lot that's happening here. You see two boundary lines. You see an overlapping shaded region, okay? So what we're going to have to do is we're going to have to write the equation of each one of these lines. Okay, so let's call this dashed line, let's call that line number 1, and let's start with that. Okay, so if you are, I've got to kind of change I've got to zoom in a little bit here. So let's see, let's find the slope of this line first. Okay, so the slope of equation 1 is 1 minus negative 2 all over 4 minus negative 2. Okay, so 1 minus negative 2, that gives me 3 over 6, which reduces to 1/2. Now, what I'm going to do next, okay, is I'm going to actually write this equation in point slope form, and I'm going to use the point C as my point. So it's going to be y minus 1 equals 1/2 times x minus 4. And that's the equation of that boundary line. Okay, so now what I'm going to do next is I'm going to figure out which direction the inequality sign goes. Okay, so again, I'm going to leave a big circle there because I'm going to fill that in. Now, if you notice, the origin is a solution to this inequality. So that means that when I plug 0 in for y and 0 in for x, I should get a true statement. Okay, so I get negative 1 on one side, and then I'm going to get 1/2 times negative 4. If I take it one step further, I get negative 1 on one side and negative 2 on the other. Now I want this to be true because, again, 0, 0 is a solution. So, whoops, let me clean that up. So negative 1 is greater than negative 2, and I use that same symbol all the way back up through the top. Now remember that it cannot be or equal to because this line was dashed. Okay, so now I'm going to repeat the same process for equation 2. Why don't you go ahead and pause the video and try to find a equation for the boundary line on number 2. Okay, well, if you tried that, okay, same process, we're going to find the slope first. So that's going to be negative 4 minus 3 all over 1 minus negative 3. Sorry, it's an ugly 3. So that gives me negative 7 on the top and positive 4 on the bottom, so negative 7/4. So again, now I'm going to write it in point slope form, and I'll go ahead and just use this point. So that'd be y plus 4 equals negative 7/4 times x minus 1. Now the last thing I need to do is figure out which symbol I'm going to use. Okay, so again, 0, 0 is still a solution to this inequality as well. So I'm going to plug 0 in for y, and I'm going to use a big circle for my inequality sign, and I'm going to plug a 0 in for x, and I'm going to simplify this. So I get 4 on one side, and I get negative 7/4 times negative 1 would just be positive 7/4. So again, 0, 0 should have made that inequality true, so we do know that 4 is greater than or equal to 7/4. Remember that it's an or equal to because of the solid line. So if we put this system together, our two inequalities, I'll change colors just to put it all together and look nice and neat. So our two inequalities, our first one we had was y minus 1 is greater than 1/2 times x minus 4. And the second one we're going to have is y plus 4 is greater than or equal to negative 7/4 times x minus 1. When we put that all together, that is our system of inequalities that would produce this graph. Well, that's all I have for you in this lesson. It's pretty straightforward, pretty easy. It just puts some concepts that we've already learned together into one. I hope it was helpful for you, and I will see you next time. Good night.